Okay, my name is Dave Brooks. I write for the Concord Monitor, the Granite Geek column, and I am one of the people who's been bringing science cafes to New Hampshire for almost 8 years now. It was started by Dan Marchek, who's somewhere around here, and Sarah Eck. Oh, there he is. And they basically were science fans. They said, gee, this is a cool idea. We've heard about it. Let's do it in New Hampshire. They sort of wrote me into it. I thought it would be a great idea that would last about 6 months and then fizzle out. And right now we have one in Nashua that Dan oversees. We have this one in Concord. And it's been so good that the Sea Museum, the Sea Science Museum in Manchester started one as well that runs down there every month. There is one in Portsmouth. I'm not sure if it started up again this year. Hanover's had them. Plymouth's had them. They're all over the place. I like to say that New Hampshire has the highest per capita science cafe rate in the country, and I think that's actually quite true. So, how many of you have been to a science cafe before? Please raise your hand. Oh, all right, I don't need to tell you much. Good. Well, for the few of you who haven't, it's a conversation, and I have to keep the microphone away from the speaker. It is a casual conversation. I'll ask the first question. I'll ask the panelists to tell you who they are. I will ask the first question, and after that is your questions. If you don't ask anything, we'll just sit here and stare at each other. And it lasts up till 8 o'clock, and if we're still going, then we'll wind up by 8 o'clock because the panelists need to go home at some point in their lives. We do this every month. It's going to be here in Concord. We're going to be the last Wednesday of the month now. Next month's topic here is going to be about New Hampshire archaeology. It's actually Archaeology Month. And I've got 3 archaeologists who do very widely different stuff, including one of them does forensic archaeology, a little bit of an overlap tonight. So that'll be interesting. The next topic in Nashua is going to be the science of gardening. Is that right? Yes. So if you want to drive down there you can see that. I think that's it. ConcordTV is filming it, so you're going to be on TV at some point. Actually, they've told me that this is quite a popular show. They share it with all the other community access television stations around the country. And for some reason, it's extremely popular in Utah. So if people stop you on the street in Salt Lake City, you'll know why.
My name is Buzz Schreier. I teach at UNH School of Law. I've been there for 25 years. Before I was there, I was a public defender in New Hampshire for 13 years, and I was assigned to do try a homicide case. I was on the public defender's homicide unit for 4 years, and one of my early cases I picked up with a colleague of mine, and it was a homicide case. It was going to be the first use of forensic DNA in New Hampshire by the prosecution. And so my co-counsel, who had a master's degree in environmental science, was very interested in it, and he signed up to go to a 4-day training session down in Washington, D.C. for criminal defense lawyers who were interested in forensic DNA evidence, which was the new hot thing. He got the flu the day before, and this was pre-9/11, so I was able to take his ticket and get on the airplane and fly to Washington, D.C., and stay in his hotel room. Now, appreciate that I was a history major in college, a colonial American history major. I took one science course in college. It was called Biology for Poets. I wasn't even a poet. I had to take it because you had to take at least one science course before you graduated from this particular college. Stupidly, I took it the last semester I was at college, so if I failed it, I wouldn't graduate. I'll leave you with this as to that. I went to more than 50% of the classes, and I passed. Thank you. So for about the first 8 to 10 years that forensic DNA was used in New Hampshire, I was leading the charge to hold the prosecution's feet to the fire in terms of forensic DNA. So I've handled probably 75, either consulted on or worked on, in this state and Massachusetts and some other states, about 75 cases involving forensic DNA evidence. And I love genetics. It's really cool stuff. Too bad I didn't become a geneticist, is what I think now. I ran with a philosopher up at Dartmouth and a geneticist up at Dartmouth. The three of us ran for almost 10 years a training session for undergraduate faculty from around the country to learn about genetics, ethics, and law. This was 3 NIH grants. And I've been doing research in that area. I've also I've written in the area of genetics and law, and I am now interested in legislation involving genetics. And any of you remember when you voted last November? Question 2, a constitutional amendment involving information privacy. Does that sound at all familiar? Which passed with 81% of the vote, not that I'm counting. I wrote that. And part of my impetus to writing it was there's a whole bunch of constitutional issues relating to the Fourth Amendment and police accessing somebody's genetic material without them knowing about it, surreptitious sampling of DNA. I'll shut up now.
Hello, my name is Kimberly Rumrell, and I've been with the New Hampshire State Police Forensic Lab for 26 years. This is my last week, however. I'm retiring from that lab and moving on to another lab.
Nothing we did, I hope.
No. Our laboratory started doing DNA in 2000. Prior to that, we used to send our cases out to a private lab or the FBI lab. And so when he was working on his earlier cases, it was most likely from another lab. FBI. And so, of course, I've done hundreds of cases during the last 26 years, and it's been an enjoyable time, but I have lots of stories and info to share.
Hi, I'm Beth Wilkes. Currently I teach at NHTI in the biology department, and I teach a couple of different level of genetics courses. Closer, can you hear me? Okay. Buzz probably would not have been my favorite student back in the day, but sounds like now he may have. But now he has an appreciation for it. So I've been teaching, like I said, like a basic level of genetics and a higher level of genetics for probably 10 years. Before that, I worked in genetic counseling, so it was more one-on-one with families that had various genetic risk factors in their family to explain to them what the risk might be if they were to have children. So that's kind of my background. It's more a little academic than the clinical and testing side of things.
We like academic at Science Cafe. And in fact, I'm going to ask you the first question. Playing the role of the doofus, as I do so well. So we're going to be talking about genetics and genes, so let's just get something straight that frankly I get confused about. So what is a gene? What is a chromosome? Just tell us how that works.
Okay, so it's not a silly question, because we throw those words around all the time, but not everyone knows exactly what all that means. But so your DNA is, or basically, a gene is just a sequence of DNA. So I'm kind of assuming everyone knows what DNA is, but DNA is made up of building blocks. You may have seen sort of pictures of DNA where they talk about them with the letters. So there are 4 bases that are the kind of the letters of DNA. And they occur in specific sequences, and a sequence of DNA is a gene. Genes code for proteins, and the DNA is packaged into chromosomes. So in a chromosome, you could have hundreds to a couple hundred genes on a chromosome. That's sort of how that works.
So a gene is a chunk of letters on that helix?
Yes. So you may have heard the term double helix. So DNA is set up in a double helix, and the gene sequences, the nucleotide sequences, the base sequences make up a gene. You have about 3.2 billion of those bases, and only about 1.5% actually make up protein encoding genes. The rest of it is more regulatory functions. So of all of your DNA, only about 1.5% actually code for proteins and are considered genes.
Quickly explain what you mean by code for protein, because this is what actually makes it work, right?
Yes.
Okay.
So the sequence of, so you have your DNA, and the sequence of bases are basically a code for amino acids. And when the code is read and the amino acids are linked together, amino acids make up a protein. And proteins basically determine everything about us structurally, how cells function, they make up different parts of the cell. And so when when the sequence is, I was gonna say normal, works properly is when we're healthy and functioning correctly. When there are changes in that sequence, then that can lead to different problems.
All right, there you go. Genetics 101. Now it's up to you. Somebody raise a hand, ask a question.
I had my DNA done through Ancestry.com.
A little closer.
And I had my ancestry done by DNA through Ancestry.com. And I know that there's other companies out there that do a similar thing. And I've been reading that some of those companies are selling that information to, let's say, insurance companies, and that could be used in the determination of whether you get insurance or not in the future. And so it's a privacy matter, Mr. Attorney.
Nobody's ever called me Mr. Attorney. There's attorney and a whole bunch of expletives. A big topic, I'll just pick off a couple pieces of it. There's one company called 23andMe. Some of you may have heard about it. They do both some testing for medical disorders and a little bit of ancestry stuff. Their primary focus is in ancestry stuff, but they send you a tube and you spit in it and you send it in and you send your $99 or whatever it is. And 23andMe does not make their money on you sending in your $99 or 100 people sending in their $99. They make their money on anonymizing your genetic profile, or what they learned about you genetically, let me put it that way, and then selling it to big pharmaceutical companies so they can do research. They're not selling it, I am not aware that they're selling it to insurance companies. I hadn't heard that. Most states in the United States that regulate private insurance have what are called genetic anti-discrimination statutes, so that an insurance company cannot use the results of a genetic test to decide whether to provide you with health insurance or to up your rate because of your genetic profile in relevant ways. There are some states that don't federally. There recently, in the last maybe 4 years ago or so, the GINA passed a genetic anti-discrimination statute, which regulates group insurance and prohibits the use of your genetic test results in that way. Maybe later on, if somebody asks a question, we can come back to the consequences, the unknown consequences of what you are doing when you give your sample, your saliva sample, to a company, and the company may interact on their own or at the request of the government with the police. in a case.
Yeah, regarding data that comes to the laboratory, it is very private. We're not allowed to even disclose DNA from one police agency to another police agency unless we have permission or certain other things are in place. Like if one PD says, well, I know that Hanover had a known sample from suspect X, we want to use the DNA profile you've got in that case to compare to our case. Now, we do that automatically. If their profile is in our database, it will hit and then results can be released in that sort of fashion. But in order for us to share a known sample submitted from one police agency, we have to ask permission in order to share some of that information with another agency. And one thing that's really awesome about the database that we have, it's called CODIS, which stands for Combined DNA Index System, is that all the data that goes in there is written in forms of letters and numbers. There are no names in there at all. So if anyone is ever able to hack the CODIS database, they would never be able to link it with a particular individual.
But my question is about the ethics of doing something other than therapeutic, CRISPR. Isn't it true that in China they actually have produced a baby girl who theoretically there was something therapeutic about what they did for her because it was eliminating the possibility of coming down with some condition. But it also increased her memory, her ability to retain information.
Maybe I'll let Beth talk about CRISPR. Well, I can talk about the ethics, but you can talk about CRISPR.
We're plunging into the deep waters pretty quick here.
Smart group.
I'm afraid to speak into this. Are we okay? Okay. So how many of you have heard of CRISPR? It's pretty good. So it is a newer technology that is a gene editing technology. I'm assuming there are many laws and regulations surrounding, no, don't assume that. There should be many laws and regulations surrounding the use of it, as you asked, therapeutically. So it's a way there are different ways it can be used, but to fix a gene mutation or to turn off a gene that you don't want to be turned on. So the research has been done in the laboratory level, but there is a lot of talk now about using it clinically and trying to possibly correct mutations in embryos or and then implant an embryo that has a fixed genetic defect. So theoretically, it's a nice thought in the sense that if a family maybe had a risk for something like sickle cell disease or cystic fibrosis, that could be corrected, and then the family would have a better outcome as far as that goes. There are still limitations, and the consequences of playing around with that are probably not fully understood. So when you do that sort of genetic manipulation, are you running a risk of altering something else in the genome, that would have unintended consequences? So it's not meant, at least right now in the United States, to be used at that clinical level. You're referring to a story that came out of China not that long ago. So I don't know if all the facts are known about that case, but that someone was, or a scientist published that he had gene edited the embryo. So keep watching. And keep watching, right?
And that editing has to be done on embryos. I mean, they can't take a cell of me, edit it, and fix my disease as an adult.
Because you have two, so we are made up of trillions of cells, so you couldn't go in and edit all of our cells, so it would have to be done at the embryonic level.
And Dave's problems are just not fixable. Sorry, I couldn't resist. Broadly, what we're talking about is something called gene therapy. And there's been a debate going on about gene therapy even before CRISPR, that tool, that newer tool, came into being, which, and Beth can correct me, but CRISPR is like a better tool than we've ever had before to go in. Yeah, it's more precise, and so you're, you know, instead of using a sledgehammer, you're using a, I don't know, ball peen hammer. That metaphor's not working. And there's been an ethical debate among philosophers and bioethicists and politicians, for that matter, about the ethics of gene therapy. Part of the debate goes like this. I'm fine, even, let's assume we can do gene therapy safely. Huge assumption right now, and we're not at that point. But let's assume we can do gene therapy safely. Do we want to just do it to fix mutations that are deleterious mutations? And oh, by the way, how we can define what is deleterious and what isn't. Interesting, raging debate for a long time in the deaf community, for example. Many in the deaf community do not believe that there's anything wrong with being deaf, and that there are many parents who choose not to have, choose not to go through a process where they can ensure that their child will not also be a deaf child. They would much prefer to have a deaf child, for example. And then the other side of it is, what about gene therapy to make you better? Yeah, some people call it designer babies. Now, many people's first reaction of, no, we're not going to do that because that's not natural. I mean, there's a lot of instinctive reactions to that, but you know, I don't really know where I am on this. I've gone back and forth on this for many years, but you know, for those of you who would never have gene therapy to make a child embryo better, I assume you would not send your child to as good a school as you could, because that's another version in a non-biological way of trying to help improve your child. The point being, it's a very complicated debate. The good news is you can't do this in the United States now. You can't get funded by the NIH or anyone to do this by their regulations. And think about what the study that needs to be done before this becomes regular. You need to round up a bunch of pregnant women and do pre-implantation genetic diagnosis and see if they have what's called a deleterious gene. And then half of them you fix it and half of them you don't fix it. And then you let them give birth to their children and let's see what happens, right? Boy, that's a scientific study that's not going to happen very soon. The let's see what happens study with real human beings. So that's just a taste of the debate.
David, you brought up the Bear Brook mystery and the evolution of the whole research and DNA ability to help solve crimes. I was wondering if I've forgotten your name. If you could, serotonin lady, if you could.
Just call her Sarah.
If you could speak to the use of these databases to, I know that was the end story but it was the culminating solution to the Bear Brook mystery murders. If you could speak to the use of the DNA databases that were out there to help solve that. And then, I know you said that your database is not for it's not publicly accessible, but the others are, the 23andMe, all these things that we use, or if we choose to. The other thing I just want to make a point to is it's not just those DNA testing sites. If you go in for a procedure and they take some of your tissue, they can use, the hospitals, the doctors can use that tissue to help maybe develop, if it's some unique something or other, they can use that those cells to help create perhaps something else and use it. You're not in control of your entire body, whether it's your DNA or your cells or anything. But anyway, I thought if you could speak to the whole evolution of the DNA resources that you had to help solve the Bear Brook murders, that would be good.
So I don't know the specifics of which companies they used and so forth, but in general, and from the literature that you can find out there from various cases, is that some agencies, including the FBI, have been using DNA laboratories that do genealogies like Family Tree or 23andMe, and they're able to take the raw data that they get from that and then upload it to GED Match, which is another company that allows you to share your raw data from your DNA profiles, that then allows you to make matches and figure out your ancestry in a somewhat different format than it happens on Ancestry.com and 23andMe. So that's one thing. When you go online, you can find that companies such as Parabon have been using these DNA profiles to establish linkages with relatives, and then they're able to take those linkages and go back and essentially, after intense investigation, yes, find out likely relative. And if the suspect, as you've probably heard, is still alive, then what they're apt to do is to tail that individual for a period of time. And if they drink a soda at McDonald's and they throw it in the trash, there's someone there to take that cup and they swab the straw and do DNA on the swab and see if it matches, samples from the case or some sort of familial type linkage. It's gonna curl his hair. And so that's sort of it in a nutshell. But one thing that's been interesting too about laboratories like Parabon is that they can take DNA, say, from a sexual assault victim, whether she's alive or dead, take, say, semen DNA from the individual and do what's called phenotypic DNA typing as well, which gives you a visual characteristic of what that person looks like. And that's also another way that DNA has been used to solve cases.
Very cool sound. You saw me having involuntary seizures as Kim was talking. Two separate issues. In terms of the databases that are being used to do what's called genetic genealogy and solve cases, I think it's a very creative and interesting investigative tool. But my concern is when you send your DNA into Ancestry.com, 23andMe, GED Match, you either electronically or on paper sign a statement saying, I agree to give this to you and you can use it for these purposes. Until this very recent case, none of those authorizations said, and if you want to give it to the police when they come to you, you can do that. Or none of them said, oh, by the way, sometimes the police come and talk to us and ask us for stuff. Until very recently, none of the companies were giving you any notice that you were giving, effectively, if the police asked, you were giving them your genetic profile or your a sample of your DNA, depending on how the company preserved it. And that's my particular problem. So you who sent your DNA off to Ancestry.com, here's a little interesting twist. Do you have any relatives who are willing to acknowledge that you're related to them?
I've been disowned.
But you still have genetic relatives, right? How many? How many within, how many brothers, sisters, children, parents?
Yeah, I have a cousin. My father was an identical twin, and his son and I.
Okay, so the Ancestry.com knows just about as much about them because you sent your DNA in as they know about you. Because DNA is, as Beth can speak of far more eloquently than me, DNA is shared. It's not like a fingerprint, which is not shared. You got your fingerprint, and you're the only one who's got your fingerprint. But 99%, it's a scary thing for Kim, but 99.99+% of my DNA is exactly the same as Kim's. In fact, 96% of your DNA is exactly the same as a chimpanzee. Is it 98 now? Yeah. So I don't intend that as an insult. I have to say that usually when you're dealing with DNA in court, it's really boring because it's all science, even though, the three of us love DNA, but nobody else does. So the first DNA case I ever tried, the homicide case I referred to, I was doing a cross-examination of the original FBI special agent who's the original DNA forensic analyst in the FBI, a guy named Dwight Adams, who later became the head of the FBI's DNA lab. And I was at the beginning, and I wanted to kind of loosen things up and get rid of the myth that, everybody's DNA is different. It is true that taken as a whole, everybody's DNA genome is different, but 99.99+% of our DNA is all the same. We're way, 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 way more alike than we are different. So I wanted to make that point with the jury because there's a lot of myths. This is back in 1992. There's a lot of myths out there about, well, if it's a DNA match, they got the right guy, which back then was just not the case. So I said, now, Dr. Adams, it's true that 99.99% of my DNA is exactly the same as your DNA. And he was from Oklahoma, a nice Oklahoma twang, but yep. And it's a scary thought, isn't it, Dr. Adams? Yep. 98% of the prosecutor's DNA is exactly the same as a chimpanzee's DNA. And he goes, yep. It was the only light moment in a 7-week-long program. Second part.
Let's stop the aerial bombardment.
Second part, what I call the surreptitious harvesting of people's DNA when they don't know about it, picking up the coffee cup that they left at Starbucks and mining it for DNA. I wrote an ungodly long and boring but brilliantly crafted law review article on this very topic, and which looked at the Fourth Amendment problem with that. Basically the issue is, do you have a reasonable expectation of privacy, not in the saliva, not in the coffee cup, but in the genetic information in the cell that's in the saliva that's in the coffee cup, on the coffee cup. And that's the constitutional Fourth Amendment issue. My argument, contrary to pretty much back when I published the article back in 2013, my argument was, and you have Fourth Amendment protection, the police need a search warrant. My argument was they can take the coffee cup, they don't need a search warrant to get the coffee cup because it's abandoned. But when they enter your cell to get your DNA, they are looking to harvest very personal, private, powerful, shared information, and that you have a reasonable expectation of privacy in, even though that DNA is outside your body. It's a really interesting little puzzle. So I'll leave you with this particular analogy that, to my thinking, of course, noting my bias, wins the day on this. About 2 to 3 years ago, the U.S. Supreme Court decided this case. The police had in their lawful possession somebody's cell phone. They went in it to mine it for information. The U.S. Supreme Court said, you have a reasonable expectation of privacy in the information in your cell phone, and even though they have legal possession of the cell phone, they need to get a search warrant to search the cell phone for information. if that's the case, they certainly need a search warrant to enter the saliva to get the information. I used to do a presentation back when that case was decided called Cells and Cells. It was quite good.
And with that, I think that's an excellent thing to wind up on. It's very nearly 8 o'clock, and we'd like to let our panelists go. So please give a warm round to our excellent panelists. I think we can all apply for continuing education credits from NHTI after listening to this.
And from the law school.
And from the law school. Yeah, who wants law school though? Anyway, so that's it. And also thanks to the staff. I hope you all take this. And we will be back here next month. If you have not signed up for the newsletter, we'll basically be sending an email saying, hey, it's coming up. And I also put you on my Granite Geek newsletter so you get my weekly thing. And then, I have a sign up over here. I'll bring it out. I'll put it on the table right here as you're leaving. You can give me your email address. And I think that's it. Thank you very much.
Thank you.